chemistry. We're looking at the atom. Atom is defined as smallest particle of matter that retains the properties of the atom. Atom was first identified by this man. His name was Democritus. He was a Greek who believed the atoms were indivisible and indestructible. The word atom comes from the Greek word atmos, which means indivisible. The Greeks believed that made out of 4 particles: earth, wind, fire, and water. Now, this man eventually changed to shift us back. His name is John Dalton, and John Dalton is the father of atomic theory. He came up with 2 laws: the law of definite composition, the law of definite proportion. All compounds are composed of specific elements, and all compounds are composed of elements in a specific ratio. All right, so it wasn't until J.J. Thompson came along, and if I can grab hold of this, Thompson performed an experiment that involved passing electric current through gases at low pressure. The result was a glowing beam or cathode ray that traveled from the cathode to an anode. Alrighty, here's what a cathode ray tube looks like. Okay, and these little particles here are electrons. They're all negative, so it's a negative beam that's moving through there. Let me show you an image of what he did. Let's go up here and over here. And this is an example of the experiment he did. He put a magnet on the cathode ray tube. It caused it to bend, which showed that atoms contain charged particles. And those, oops, spelled that wrong. Atoms have charged particles. Those particles are protons, positive, neutrons, negative, neutrons, neutral, electrons, negative. Now, from that, he came with the plum pudding theory, which basically said an atom is just all the charges lumped together. Now, Ernst Rutherford, the model of the atom turned out to be short-lived. However, due to the work of Ernst Rutherford, don't worry about death and birth dates. I don't care. Okay, and here is Rutherford's experiment. He fired a particle, which is called an alpha particle. An alpha particle is 2 protons and 2 neutrons. Okay, and that particle, if Thompson had right, would have bounced it right back. But unfortunately for Thompson, it didn't. And let's show an experiment that explains that.
10. Rutherford and his co-workers were studying the angles at which alpha particles
You see,
were
most of them are
scattered
going
as they
straight
passed
through.
a thin gold foil. Most of the alpha particles passed through undeflected. However, a few were found to be scattered at large angles, some even back in the direction from which they had come. This meant that they had collided with an object much more massive than the alpha particles themselves, yet so small that only a few alpha particles encountered them. This atomic level view shows what is happening. Most of the atom is occupied by the low mass electrons. The nucleus is small and massive. When an alpha particle encounters a nucleus, it is scattered at a large angle.
All right, so let's take a look. What are we saying? According to Rutherford's model, atoms composed of mostly of empty space, all the positive charge and regions, small area called the nucleus. The nucleus is the tiny core of the atom that is composed of protons and neutrons. So here is Rutherford's theory. Protons and neutrons, positive and neutral, and electrons just sitting out there. Now, he was quickly corrected by a man named Niels Bohr. Bohr said the protons and neutrons, but the electrons follow a well-defined path. Now, we now know that that's not true thanks to this man named Werner Heisenberg. Heisenberg came up with what's called the Heisenberg uncertainty principle, which said either an electron's position or velocity can be determined, but not both, which would make Bohr not possible. So this is what we have now today. Our nucleus is in the center. Electrons are in a 3-dimensional space called the electron cloud. That's how we extend the atom today. We're done. Take care. Be good. Bye.